Wait a little bit, Verdugo. Okay, yeah, it's 2:30 o'clock. So, okay. Um, Today we are going to talk about polygon transformations, translation, sorry. This is a translation, uh, rotation and reflection. José Espejo, Samuel Arias. Uy, a lot of people is getting inside. Okay, so why are we going to talk about this? Because we saw it last year. Okay, mucha gente está entrando al tiempo. Okay, we saw it last year, but we actually need to remember those topics in order to be able to continue with more advanced topics. Because today we're going to remember um, the three transformations that we saw. I think that it was the first term of the last year. Um, and also, when we finish that, we can start learning about more polygon transformations different from them because there are more. It's not only these three. So, ay, Dios. Okay. So, let's start by remembering what is a polygon transformation. And here you can see in this slide that any modification that you can make to the properties of a polygon can be considered a transformation. For example, I am going to open GeoGebra. GeoGebra. That is a software that you can also use on your own because it is online. GeoGebra Clásico here because it has many functions. And here you can make a lot of constructions and many things. So let me make a polygon. Let me make a triangle. Yes. Oh, this is not a triangle. Sorry. This is um, quadrilateral because it has four sides. So if I change the position of this point, that is a transformation. Yes. Or if I move the complete polygon to another place, it is a transformation. Yes. Or if I make it bigger, that is a transformation. But we are going to only, teacher, ya, no me pueden ver. Disculpen, chicos. Qué pena con ustedes. Permítanme lo arreglo, ya sé por qué sucedió. Mostrar mi pantalla, toda la pantalla. Ok, ahora sí me ven, ¿cierto? Yes, can you confirm in the chat? Okay, thank you very much. Sorry about that. I was only sharing the PowerPoint presentation. Okay, here I drew a polygon, which is a quadrilateral, as I was telling to you, because it has four sides. Mm? So imagine that I changed the position of the point A. Well, I transformed the polygon. That is a transformation. That is a change that I made. What if I move it to another place? That is also a transformation because I changed the position. Or what if I make it bigger, like here? That is also a transformation. Yes? But we are going to only focus on some transformations that are called isometries. Look, this word. But don't get scared about this word because an isometry is really simple. It's a transformation that doesn't change the shape. So let me ask one person. Okay, I am going to ask probably, let me check, random, here. Nicolas Trujillo, please talk. How are you, Nicolas? Nico, Hello, Nicolás. Hello. Ok, ¿quién es gerencia ventas? Buenas tardes. Nicolás is not talking. F. Okay. So I another person. Juan Diego. Hello, Juan Diego. I know that you are paying attention. That's great. Juan Diego. Hello. Verdugo. Verdugo, please. Okay, anyway. Wilson. Ah, okay, no. Verdugo, please talk. Please, please, please talk. Hello. What happened, Juan Diego? Talk. You were talking. Hello. Yes. F. Okay. No, no, no problem. Maybe he's Wilson. 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 Yes. Wilson is talking. Hello. Mm, okay. I don't know what happens, but you're not talking. So I assume that you don't want to participate or that you're having a lot of issues. So I am going to do this. Remember, an isometry is any change that you can make to a polygon such that its position is not the same. So it changes the position, but its shape, remember, shape es la forma, remains congruent. And congruent means that it's exactly the same. Mm? So if I make this, I change the position of the point A, but the shape changes. So it means that that thing that I made is not isometric. If I make, for example, this, that is also not an isometry because the shape changed. But what happens if I move it? If I only move it? It is an isometry or not? It is an isometry because the shape didn't change. The shape is exactly the same. That is an isometry. So moving it across the grid, across the board, is an isometry. But what happens if I make it bigger or smaller? Let me ask Chala. Hello, Chala. Can you please talk? Juan Andres.
Hello,
Hello, ¿cómo estás, Chala? How are you?
fine, and you?
Fine. Okay, Chala. I have a question for you. If I make it bigger or smaller, is it isometry or not?
Note,
Why?
mm,
You are right, but why?
because you not move the
The figure?
this
More or less, because the position actually changed because it is occupying more space right now. But it is not an isometry because the result is not congruent. And remember, congruent means that it's exactly equal. It means the shape and the size. If the size changes, it is not an isometry, okay? Is it clear, or does anybody have any question about it? If you have questions, please talk right now. Okay, you will have time to copy next hour of math, I think tomorrow, when you develop an activity in Alex, which is really short, and you have time to copy. Anyway, the slides are already here in the Padlet. Look, here you have it. And you can interact with them because I created something interactive there. So, no questions about it. So let's start by checking all of the three transformations or isometries that um, are actually isometries. So I am going to copy this link because that link will take me to a page where there is a material developed by another person called Jason Wofsey. I don't know how his last name is pronounced, to show you all of the isometries. So the first one is called a translation, and in geometrical context, it is not traducción, translation. Cuando hablamos en geometría no es traducción, sino se traduce más traslación, sin la N en español. ¿Listo? And it means only moving the figure across the board. So for example, here I have a figure. Yes? And I can change it. Look, I can give this figure the shape that I want. Mm? So let me, no, esta no, that one. A translation is only, let me show you the definition, is an isometry that changes the position of a polygon without flipping it or turning it. And remember, flip means voltear and turn means girar. So it doesn't flip or it doesn't turn. It only moves vertically or horizontally, or a combination of the two, like this one. This arrow is going to tell you the motion that we make. Mm? So you can see it like moving a little bit to the left and a little bit down. But here you can see it at the same time. It's the same. So look what happens. It is moving. See, yes. So the yellow polygon is the original polygon, and the purple one is the result. We call the result an image. Yes, an image. And we use these little commas over the points, these apostrophes, to symbolize that that is the result of a transformation. Yes? So, what happens if I move the arrow? It only indicates the motion and how much it changes or not. I think I have a question. I have a question here. Yes, Natalia, what happened? Okay, so right now, do you have any question about what translations are in geometry? If you have it, please talk right now. And I can see who talks or who doesn't. No questions? The same, Juanes. You have time to copy the next hour that you have autonomous work. So that time you can take notes from the presentation that is here in the Padlet and also develop an activity in Alex. But I think that class is tomorrow. Let me check the schedule. Yes, tomorrow. But tomorrow, yes, tomorrow. Tomorrow, the first hour is autonomous for you, and the second one we have class like this. So no other question, I think. Okay. Who's Acción Social FAC? ¿Quién es Acción Social FAC? Buenas tardes. Okay, anyway. So the next one. Here I had the same. Miren, aquí estaba. The same. I'll say something in Spanish, kids. Chicos, estas diapositivas las pueden descargar y va a aparecer tal cual. Pero muy probablemente a ustedes no les aparezcan estos recuadros con las construcciones geométricas, porque para eso se necesita un complemento de GeoGebra que yo instalé el otro día. Pero no se preocupen, ¿por qué? Porque aquí yo les puse a todos los links para que los lleve a estas páginas en el navegador y desde el navegador sí van a poder verlo, no tienen que descargar ni instalar nada, porque eso es completamente online. Y aquí como pueden ver, vamos a ver la reflection, rotation, unas preguntas para ustedes ahorita que les voy a hacer y demás. Okay, so let's talk about reflection, which is this one. Okay, and a reflection is an isometry. Remember, isometry doesn't change the shape. That flips. And remember, the word flip means voltear. It flips the figure using a symmetry axis. And what is a symmetry axis? A symmetry axis is this line, a line, to act as a mirror. So imagine that this line is a mirror. So this polygon, this triangle, was the original figure and it reflected its image over the mirror. Mm? So you know that in real mirrors, the things are flipped, están al revés. So the same happens with polygons and reflection axis. Other important thing, that symmetry axis is also the bisector of the segments formed when you join every point with its image. So I am going to talk to ask one person to answer me some questions to help you all understand this better. So Santiago Ramirez, hello.
Hi,
How are you, Santiago?
fine, and you?
Fine, fine. Okay, I have a question for you, Santiago. Look, do you remember the meaning of bisector?
Yeah,
What is a bisector?
is like the mirror, but it divides the place into equal
Exactly,
sectors.
exactly. Yes, yes, yes. A bisector is a perpendicular. Remember, that is really important. Bisectors are always perpendicular. So if I make here, I don't know, this. A bisector is a perpendicular to this one. So it has to make a right angle with this line. But that is one condition, but the bisectors have another condition, which is going exactly through the middle, like Santiago said. So we did it in this way. We made a circle, which muy grande, don't worry. We made another circle. Uy, ¿qué pasó? Sorry. We make another circle. We put the intersection points, puntos de intersección que se me hicieron here. We put these intersections with these intersections and we join. Mm? Remember that we did it last term in Alex and in with compass and paper. So this is a bisector. Why? Because it makes a right angle. No, no pude. Tengo que poner otro punto. It makes a right angle. You see, 90 degrees, but it also divides exactly into equal parts. So let's go back to reflections. What happens? That this is exactly perpendicular to the lines that join the 2 points, like the original and the image, but also splits this line in exactly two equal parts. You cannot make, let me open this and let me do a drawing for you. You cannot make this. For example, imagine that this line doesn't exist, but this is the original and this is the reflection. You cannot say that the mirror or the symmetry axis, remember, that is the name, is here. It cannot be here. Why? Because this part is not the same than this part, right? Or another thing. Another thing. You cannot say that, for example, sorry. You cannot say that, for example, you have this figure. Perdón por hacerlo tan mejor. Perdón por hacerlo tan feo. You cannot say that you have this figure and you have the reflection. Recuerden que está volteado. But you cannot say that this is the mirror, that is the symmetry axis, because look, we have to join this one. Tenemos que unirlos todos para comprobar. And this is not perpendicular. And also, the two parts are not equal, right? So let's check what happens here in the construction that I have in the presentation also. I have it here, actually. Look. Here we have an original figure. This is a quadrilateral also because it has 4 sides. Parece un triángulo, pero no lo es. Look what happens if I change it. Hmm? So this line is the symmetry axis. Remember, the mirror. So I am going to move this slider, and you see that we create a copy that is going to flip slowly is flipping until the other side, and it is exactly equal. If we move it, look, the reflection moves accordingly. And the distance, look, the distance between, for example, D and D shortens, but the part from D to the line and from the line to the image is exactly the same. So let me show you with the grid. And let me put it perfectly. You can say that if we join this, if we join this, and if we join this, from here to the mirror, from the symmetry line, the symmetry axis, it is one diagonal. And from the line to the image is also one. What happens if we do it with E? From E to the symmetry axis is 1.5. And from the symmetry axis to the image of V is also 1.5. It's always the same. And if we move the figure, remember, you see it maintains. It's exactly the same. And even if we change the shape of the figure, it's always gonna stay. And even, look what happens if I move the mirror, if I move the symmetry axis. You see that it is moving, and they are all sorry, they are only perpendicular always, and the distances are always exactly the same. And even if I change it from side, the other one also changes side. Remember, kids, you can do it on your own when you download the presentation. And if it doesn't work, you can get inside the link. So is there any question about reflections? Please say it through the chat. No, 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 no. Okay, I think not. Perfect. So, kids, now let's talk about the final isometry. Remember, isometries never change the shape, only the position. Nor the size, el tamaño tampoco cambia. Okay? The next one is a rotation. Rotation. And so a rotation is an isometry that spins the figure. And spin is a synonymous of turn or rotate, which is girar. It spins the figure. It means that it moves the polygon around a fixed center with a determined amplitude. So, este sí no abre. Voy a abrirla. I am going to open it here. That's great. So here we have a figure. Let me actually do it a little bit longer. Longer, no, bigger. mm, So you can see it better. And we need two things in order to make rotations. Apart from the figure, we have the figure, and we need two more things. One is the point or the center of rotation. So it can be in any place of the plane. It can be outside, it can be inside, it can be exactly in one of the vertices. We will see it later. And it will tell you from where it spins. So it is always at the same distance from all of the points to the center. Okay? And the other thing that you need is an angle. So this slider represents the quantity of an angle. So let me show you what happens when we increase that angle. You see a copy is created, an image, and you see that it is rotating as long as the angle increases. You see? And when we get to 360 degrees, it completes a rotation. Pero se nos pasó. No, no problem. And we can continue. We can do it from one place to the other. And look what happens. It has rotated 35 degrees. ¿Vale? So look what happens in the figure. I am going to measure the angles from some points going to through P and ending in the image. So let's start with B. If we measure from B to P to B prime, que es la imagen, 35 degrees. So let's do it with another one. Let's do it with D. From D to P to D, and it's also 35 degrees. And let's do it with another one. But I'm pretty sure that you already know the answer. If we do it, let's say F, that you like that letter too much. So from F to P to F prime, it is also 35 degrees. But if we increase the angle, let's say, wow, 80 degrees, it is also increasing. And the others are also gonna increase. Now, let me change a little bit the figure. You know that if I do something to the original, the the image also changed to maintain the same shape, because remember, isometries never change the shape. But okay, look what happens. Voy a ponerlo en cero. Let me. It's really difficult. You see, it's really really difficult. Oh, finally. So look what happens if I put the point over the point F. What is going to happen is that, I'll say this in Spanish. Imagínense que ustedes colocan un chinche en el punto F y empiezan a rotar la figura. That is what is going to happen, look. Mm, Because the point F and F prime from the image are connected, but the rotation still happens. So let me put it again in 0. Oh God, it's difficult. You see? Perfect. Now, sorry, voy a hacerlo un poquito más grande. Look what happens if I put the point, the center of rotation, in the point inside the figure. The same is going to happen. It's like putting a nail. It's like putting a nail in the middle of the figure and start spinning it. The figure stays in the same place, but it rotates. Look. And that is it. Yes. So is there any question related to rotations like a compass? Yes, Wilson, exactly like a compass, because what you are doing with a compass is exactly rotating points. Mm? And how do you do it in paper, the rotations? Well, you do the same. So let me try to do it here. Ay, Dios mío. So let's say I put this another triangle, this one. Mm? And I have to put a center of rotation that maybe here. And with a compass, uh, okay, here in GeoGebra is faster, but it's more difficult to explain because you have to first create an angle with a determined amplitude. For example, let's say 45 degrees. ¿Listo? Y esa es la misma distancia. Okay. But you do it for all of the points. M, 45 degrees. You see? And finally, the other one. And 45 degrees. Hacerlo en físico es un poquito más complejo. And then finally, you have the rotation, and it's exactly the same figure. So let me see if I can change the measure of the angle. I don't think so, but it may be possible. Ángulo alfa. Ah, no, 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 no. No, los tendría que cambiar todos si se modifica la figura. So no problem. That is how you do it in paper with a compass and with protractor, because you need the protractor to make the same angle always. So once again, is there any question about rotation? No, thank you, Maria Paula. Perdón, ¿quién es Máximo Coco? Chicos, un favor, no sé si ya les dijeron en tutoría, pero pues es necesario que ingresen a las clases con cuentas que tengan sus nombres de verdad, porque necesitamos saber quién está entrando a las clases, quién no está entrando a las clases, y pues es bastante molesto tener que estar preguntando quién es Máximo Coco, quién es Batman Camargo. Eh, entonces, pues por favor, chicos, eso es importante, y no como castigo, porque pues el hecho de tomar la asistencia no es como un motivo de control y castigo, bueno, sí es un poco control, pero para saber quiénes tienen dificultades para ingresar, quiénes digamos que tengan varias personas y solo un computador, pues como para poder ir teniendo registro de esas situaciones y pues poder actuar de acuerdo con eso. Bueno, so now I am going to select a random person. Natalia. Hello, Natalia. Please open your microphone. How are you? Natalia. Natalia ya no está. Hmm. Bueno, otra persona. Sí, Wilson, sé que eres tú, pero pues pon tu nombre igual. Sara Matiz is here. I'm pretty sure that I saw her. Sarita, please talk. Sara. Okay, I trust you. So anyway, Sara, you are going to answer me through the chat. Chat. Okay, so the next one, the next construction is a mystery isometry. So here you see a yellow figure, which is the original, and here you see a blue figure, which is the image. I can't, I cannot modify the image, but if I modify the original, the image changes. So looking here, Sarah, what isometry do you think that this one? Reflection, rotation, or translation? Look, and if I move it, look what happens. Let me see, Sarah. What do you think it is, Sarah? Reflection, you think. Quítale el am, ¿vale? Ahí no se usa el am. So yes, you are right. Look, a hint. Here you see the symmetry axis, which is this one. And if I move the symmetry axis, the reflection also changes. Yes, to maintain the perpendicularity between these two things and the same distance between the image and the mirror. Okay, thank you. So next person, Camila. Hello, Camila. How are you? Camila is here? Yes, Camila is here. Yes, Samuel, it's about this topic, but you do it tomorrow in the first hour. Camila, hello. Camila is not listening, so Verdugo, yes, please talk. No, pero ahora todos tienen mis problemas con el micrófono. Eh, verdad, Verdugo no puede. Anyway, so Verdugo, next one. What is this? Let me move the original and you will see. What do you think is this one? I am moving it. Translation, reflection, or rotation? Okay, Verdugo, ready? Translation. Yes, it is a translation because you are moving it exactly. You are moving it without flipping or turning. And look here, you have the vector that are always called a vector that represents the direction and the amount of motion. So yes, you see if I modify the arrow, it changes. And next person, Mario, are you there? Are you here? Sorry, here. Camila, Cata, Herencia Ventas. Mario is Gamer Top. No lo veo. ¿Mario está o no está? Parece que no está. Another person. Pinilla, Pinilla. I'm pretty sure that Pinilla is here. Hello, Pinilla. Can you talk or do you also have microphone problems? Okay. Okay, let's look at the next isometry. Look, I am going to move it. And you tell me if it is a translation, a reflection, or a rotation, right? Think about it, Pinilla. Okay. Okay, and Simon want the next one. Yes, but the next one is a little bit more difficult, Simon. But no problem, you can. Uy, te ganó. Gerencia ventas, te ganó, Simón. Pinilla, tell me through the ah the teacher. I can tell you the answer by chat. It's reflection. Ah, reflection. No, Pinilla, it's not a reflection because a reflection flips. Yes, flips, but it is perfectly symmetrical through a mirror. And if you make a line here, imagine that you make a line here. That is not a mirror. Or if you make it here, still is not a mirror. But look what happens when I click here. Here you have an angle. You see, it's a rotation. It is a rotation because it flipped, but it not actually flipped. It actually turned. You see? And if I move it, the angle moves and the other figure also moves. You see? If I move this one, it also. Okay, thank you, David Alejandro. And Simon Linares. Do you also have microphone issues? Or can you talk? No, no tiene eso. ¿Listo, Simón? I don't understand, Simón. Can you talk or not? Escucho a alguien, pero you cannot talk. Okay, so look at the next one. Hmm? So this one is a little bit more difficult. Don't worry, it's not extremely difficult. It's just that it is two transformations in one. Yes, you do two of them. So you do one transformation, and to the result, you make another transformation. So let me move the figures so you can see if it is what transformations they are. Think it carefully, okay? I'm going to make this. Look what happens if I move it like this. But what happens if I move it like this? Okay, Simon. So do you know the answer or do you want me to help you? Okay, reflection. But remember, there are two transformations. So you say that one is reflection. What is the other one? Let me move it more. So Simon, what is the other one? Simon, did you die? Hmm. Okay, Wilson wanted. Wilson, answer to me the other transformation. Look, Simon said reflection, and yes, we make a reflection, but there is another transformation also. So, Wilson, do you agree with Verdugo or not? Well, yes, because we only have 1 minute left. The transformations are reflection, because look, here we have the original and we made a mirror, a reflection. Yes, this one. But to this one, we make a translation. Look, if I change it, it changes. So, kids, tomorrow at the first hour, I am going to activate to you an Alex test. Don't worry, it's not graded. but it is for practice, in which you have to practice these concepts. And if you have any question during that time, don't worry, because I am going to be answering through videos. So kids, thank you very much. I think that you have other class, so please go and be on time. Goodbye. Thank you very much. Bye bye.
Sonos, profe, ¿cómo le ha ido? En esa asociación.
Que en esa asociación. Es que.
Ay, mamá. Hola. Hola, vale. Hola, Pinilla. Bueno, chao.